So many A-level maths students fail to score any marks at all in this A-level maths question. Let's see if you could score full marks. Part 1 asks us to work out this integral for 2 marks. You might be wondering, I've got a quadratic here in the denominator. Maybe I could factorize that and use partial fractions. Well, look at the number of marks. It's only worth 2 marks. Do you think that this is going to be a partial fractions question? No. Some of you might also be wanting to rewrite this with a power of -1, but also that's just not going to work. In fact, the trick here is to realize this is an integration by inspection problem. What you need to notice is that if you differentiate the denominator here, you get 6x minus 4 plus 0. So 6x minus 4. And 6x minus 4 is related to the numerator. If you double 3x minus 2, you get 6x minus 4. So that's suggesting that this integral can be evaluated using a natural log approach. Let's see how it works in detail. So let's try differentiating the natural log of the denominator here. How do we differentiate a natural log? Well, when we differentiate, the natural log goes away and we get a fraction. On the bottom of the fraction, we copy and paste what we have here. And on the top of the fraction, we have the differential of that. So if we differentiate 3x squared minus 4x plus 5, we end up with 6x minus 4. That goes on the top. So as I was saying, 6x minus 4 is a multiple of 3x minus 2. In fact, it's double it. Notice that what we've got here is exactly what we have in the integral that we started with. But we're missing this 2 here. So I could multiply the integral by 2. But if I've done that, then I would be changing the integral. I need to cancel out that multiply by 2 by dividing by 2, or equivalently multiplying by a half here. So how does this help us? Well, we've got a half, and then this integral here, what do we differentiate to get this part? Well, we differentiate this part. So this whole integral is going to become this natural log. So that's going to go in this spot here, and we mustn't forget at the very end that whenever we've integrated, we need that plus c, the constant of integration. Do you need to write down all of those steps? Absolutely not. I've done so to help you to see my thought process, but actually here, we get the 2 marks just by writing down the answer. If it helps you to write down the working, absolutely go ahead, but you don't need to. The technique that I've shown you here, multiplying by 2 and dividing by 2, works because 2 is a constant. It doesn't involve an x here. I wouldn't be allowed to multiply by x and divide by x. That is not allowed. Lots of students seem to think that they are allowed to do that, and you can see from the examiner's report that some students attempted to do just that in this exam, and it scored them 0 marks. In fact, if you're still not convinced that this isn't correct, why don't you try differentiating it? Because remember, differentiation is the reverse process of integration. If you differentiate this, well, you're going to need to use either the product rule or the quotient rule. Either way, when you differentiate this, you'll see that you get something much more complicated. It doesn't retrieve the original integral. Similarly, lots of students get a bit confused with them, should I be multiplying by 2 or dividing by 2? And some confused it in the exam, and it only scored them 1 mark out of 2. Part 2. Evaluate this integral for 2 marks. Let's start by calling the integral I, just so it's easier to write later on. So, how can we evaluate this integral? Well, you might be thinking, we've got a fraction again. Is this a natural log? Well, actually, if you try it out, you'll see it doesn't work in this case. Instead, what you need to do is to rewrite this part, the denominator, using a negative power. So rewrite it with a power of -3. What I want you to notice is that when we differentiate inside of this bracket, we end up with 2e to the 2x. And on the outside of the bracket here, we've got a multiple of just that. We've got an e to the 2x. So that's suggesting to me that perhaps a good candidate to try differentiating to end up with something like this, a multiple of this, would be this bracket, but with the power changed. Remember, when we differentiate, we subtract 1 from the power. When we integrate, we're going to add 1 to the power. So let's add 1 to the power. If we add 1 to -3, we end up with a new power of -2. So let's try differentiating this and see what happens. How do we do that? Well, we take this power and we bring it to the front. That's the first thing that we do. Then we take the contents of the bracket here and differentiate that, and that comes to the front too. We get 2e to the 2x. Then we copy down this bracket, but we subtract 1 from the power to get a new power of -3. Let's just tidy this up a little bit. This part is going to give us a -4 at the front. Now, can you see that what we've ended up with here is very similar to what I'm trying to integrate? And you see that this part is exactly the same as this part. But I've ended up with this -4 here. So how am I going to evaluate this integral? Well, I've got to account for that -4. What I could do is think, well, I need a -4, so let's multiply by -4. But there wasn't a -4, so I need to divide by -4, or equivalently multiply by -1/4. So we've got this negative a quarter here. And what does this integral become? Well, what do we have to differentiate to get this? Well, we've shown that you have to differentiate this. So that part is going to replace this integral here. So we get negative a quarter, then that bracket with the -2, and don't forget the all-important plus c at the end. Again, do you need to write down all of those steps if you're working? Absolutely not. You only get the 2 marks for the answer at the end. But if it helps you to write them down, please do. Here you can see some common incorrect answers. Some students tried to divide by a function of x in the exam. It scored them 0 marks. Some students tried to take a natural log approach here. Again, it scores 0 marks. If you're not convinced, try differentiating it. You'll see it doesn't work. And some students got a bit confused about the need for a negative sign, and they also tried to divide by e to the 2x. It didn't score them full marks. Have you got another way of thinking about these integrals? Maybe you prefer to take a substitution approach. Let me know in the comments.